Hello everyone, and welcome to one of the tutorials by Mario Tutorials. I am Mario, and I'm hereby demonstrating the derivative of e to the x. Now, I've watched several other videos on this matter, and they're not complete. I think this one will be much better because I actually explain everything from the very definition of E. And most other videos just explain from a limit definition that they don't explain how they got there, or they just say it's e to the x. What most of the times you will see is people explaining that by going through the normal limit definition of a derivative, and they'll just end up with something like that, saying that e to the h minus 1 over h, and he'll just say, oh, this is simply 1, which means the end result will give us that e to the x, the derivative of e to the x is e to the x. Is e to the x anyway. Sorry about that. But I'm actually going to demonstrate it from the actual definition. I've also seen people demonstrating it, and that's why I didn't like it. I didn't like most of the videos. I've seen people demonstrating it using the Maclaurin series. Now, you can't really demonstrate the derivative of e with the Maclaurin series, or the Maclaurin expansion, as you wish to call it, by the simple reason that those theories were built upon the concept, built upon the idea that the derivative of e to the x is e to the x. So it's already predefined to be that way. So it's like winning a rigged contest. So, okay, let's start by the definition of E. What is E? E is defined by a limit, and and this is the limit definition of E. So, oops, sorry. Always making this mistake because this is infinity. As h approaches infinity, of 1 plus h raised to the power of 1 over h. This is the definition of E. Now, let's manipulate this a little, and let's actually say that let h be equal to 1 over h. So what I mean by that is let E equal the limit of h as it approaches 0 of 1 plus, sorry, that's the other way around. It's the other way around. I'm used to writing the other definition. And that's it. That's the actual definition. And here we are wanting to transform it to this definition. So we have h approaching 0. Now, we can do that because, well, obviously it's simple math, but I'm going to explain it anyway. Let's say we have a limit as x approaches 4 of x plus 2. Obviously, this is a simple substitution, 4 plus 2. Actually, let's do it in another way. Yeah, this works, but let's do it in yet another way that is actually more intuitive. So let's say x approaches 1/2, and we say x plus 1/2, and obviously this is equal to 1. Now, now, Sorry. Now we can, my microphone is off. Sorry about that. My microphone is falling apart for some reason. Now, what we could say here is, we know this is equal to 1, but it's the exact same thing as saying, let x be equal to 1 over x, and say, if 1 over x if x, instead of x we substituted by 1 over x, we're saying that 1 over x approaches 1/2, which means x approaches 2, or the inverse of that. So it's the same thing as saying the limit as x approaches 2 of 1 over x, because we're substituting every x by 1 over x, plus 1/2. And this is actually 1 over, sorry, this is not it. Well, that is it, but that's a later step. So 1 over x plus 1/2. And this equals what? If we do simple substitution again, it's 1/2 plus 1/2, which equals 1. So it works, it's simple math, but I thought I'd explain just to be thorough. And this is a thorough guide, so I want to be thorough there. I'm also going to explain something else, by the way, which is related to this, which is the fact that I passed from infinity to 0. So we know that theoretically, c over 0 approaches or is equal to, let's say, infinity over 1. There is a demonstration that proves this if you want to question the actual demonstration, but we're questioning another demonstration, which is the derivative of e to the x, but we're assuming this is right. But there is an actual demonstration for that, so you can go check that out. So we're basically saying that 0 over c equals 1 over infinity. So the inverse of infinity, which is what we want here, h approaches infinity. If we substitute by 1 over h, it's 1 over h approaching infinity, which is h approaching 1 over infinity. And 1 over infinity equals to 0 over something, which equals 0. So that's why we can do that. Now that every bit of it is explained, I'm going to continue. Actually, this is what I meant to end up with. So I manipulated the very definition of E, and reached this expression. Now we're gonna put this expression on hold because we're gonna work on another one. But so let's So what the hell? Cool. I can do that sometimes, but not every time. What's going on? Okay, I got it. Seriously, sorry about that. It's just that I'm a noob. Let's keep it here. And let's work on another thing. Let's say that f of x equals e to the x. My mic again. Sorry if you listen to a very loud noise. It's my mic, but he sucks. It sucks, not he. It's not a guy yet. There you go. So we want to know what f prime of x is, and by definition it's f of x plus h minus f of x over h. This is the very definition of the derivative. Okay, we can go again defining the derivative. If you want to watch a video about the actual definition of the derivative and the demonstration, which is pretty straightforward, but go ahead and watch one of the other videos I have made. And if you substitute it by the actual function, it's e to the x plus h minus e to the x. It's the same thing as saying e to the x times e to the h plus e to the x. If you remember that rule, if you have the same base, it's and they're multiplying, you keep the base and you add the exponent. So e to the x times e to the h, same thing as e to the x plus h, which is what we have there. And now we can actually simplify this as saying e to the x, open parentheses, e to the h, because it's e to the x times e to the h, shouldn't be, sorry, this is minus and I put a plus there for some stupid reason. Minus 1. And this is the final equation expression I wanted to get. I didn't put it here because it's, well, it's almost normal, but yeah, it's incomplete. You actually needed to add a limit here. This is not like that. It's a limit as h approaches 0, but it's almost implicit. So what I'm going to do at the end is I'm going to use this final expression we got there. Oops. I hope I'm explaining it well. If I'm not, because I sometimes think that, well, the limit is implicit and some things are almost implicit. Sorry about that. It's just, I do it like that sometimes. Now. So what I'm actually saying right here is that f prime of x equals to the limit as h approaches 0 of this. Okay. Now let's put this on hold a little, and let's work on our other expression here. Let's say that we raise both the members of the equation by h, so making e to the power of h equals the limit of h to the 0, approaching 0, 1 plus h, 1 over h, and now raised to the power of h, raised to the h, as I did here as well. I can do that because it's a limit property. The product of two limits is the same thing as, like, limit of a function a times limit of a function b is the same thing as saying limit of a times b. And the sum, and for the sum and subtraction, same thing. Loads of demonstrations about that you can go and watch. Also, this is so multiplying something outside the limit is the same thing as multiplying it inside the limit. So I can just put the h here instead of taking the whole limit. That will help us here, where I simplify this by saying that e to the h equals the limit as h approaches 0. So this cuts with that, because 1 over h times h equals 1. Also, there's a demonstration why you have you can do this when it's in parentheses, but that's basic math. And we end up with 1 plus h here. So now let's use green for our big conclusion. Notice that let's go to our f prime of x over h. E to the x. Now, you have an e to the h here. See? E to the h there. Now, when we're putting limits, when we have h approaching 0 anyway, and we have the same variables, we can just plug that in. So e to the h equals that. We're already in the limit. This is not correct. I implicit that, but it's not correct. You have to put in the limit, obviously. H approaching 0 of e to the x, e to the h. No, actually. Sorry. You substitute it by e to the h, which is 1 plus h, minus 1 over h. And this gives you e to the x times 1 cuts with 1, h over h. This cuts with that and gives you e to the x. So as a big fat conclusion, we can say that f prime of x equals e to the x. And f of x obviously equals e to the x. So this is our big conclusion. And there we go. Demonstrated it. Sorry if it's a bit confusing. It's my first video actually on this board. I can normally do this on normal, regular, actual boards. And when we're doing it on a computerized board, everything is bad. Actually, I think I can, yeah. But thank you for listening, and thank you.